top of page 489 at that green box. We're going to talk about graphing logarithmic functions. And of course, they're going to go through the transformations again, and the transformations are going to work just like you're accustomed to making them work on all the other things, with H and K and so forth. So looking at the green box, the concept summary at the top, it says the graph of the function y equals logarithm base b of x minus h plus k. Actually, they don't even have a in here, so that's good. Has the following characteristics. Okay, you're going to have a vertical asymptote. That means the graph's going to get really close to it, but not cross it, at the line x equal to h, because you can't really take the logarithm of the number 0, okay? So that's kind of like a domain restriction. Try to put that in your calculator. You're saying, what do I take take log base 10 of 0? What do I raise the base 10 to in order to get 0? Well, you can't do it, right? So that's why this function is undefined at 0. So if you have an h in there, then you're going to have a vertical asymptote right there, okay? And the other part is the domain. The domain, you're not going to be able to take you're not going to be able to take the logarithm of any negative numbers, right? Because you're taking these bases and raising them to various powers, and so so therefore you're always going to get like a positive number. So the domain is always going to be x, and it has to be greater than h, right? Because this is minus h. So this is like a shift, um, you know, to the right, or whatever the opposite of h, whatever h is. Okay, so it has to be greater. The domain's going to be greater than h, and the range is all real numbers. Okay, now remember, when we were talking about our exponential functions, remember I was saying that exponential functions are the inverses of logarithm functions. Remember that the domain of an exponential function is all reals, and that the domain, if it was untransformed or whatever, the domain was always greater than 0, right? Well, this in a way is sort of reversed. Of course, they're putting an h in here, so it's not 0, so it's h. But if you didn't have the h there, your domain would be all x greater than 0, and then the range now is all real numbers. Okay, so it's the reverse of an exponential function. And then the last line says, if b is greater than 1, so that means your base is greater than 1, the graph moves up to the right. Okay, if b is in between 1, so in other words, the exponents are going to be negative, right? Because you're going to have a fraction. If it's between 0 and 1, then the graph is going to move down to the right, because you're really going to be dealing with negative exponents ultimately, because when you have a fraction and you're raising it to some sort of power, remember you're raising it to a negative power. All right, so let's look at example 7 and see if we can graph this. So it says y equals logarithm 1/3 x minus 1. All right, so it says plot several convenient points. Okay, to plot a few convenient points, I mean, you can do this one of two ways. Okay, one way would be to figure out the points for the exponential function, the inverse of 1/3 to the x. Okay, that's one way to do that. And so if you did, and then swap the x and the y, and then graph it. So if you put a 0 in here, what's y equal to? Well, that's equal to 1. And then let's say if you put a -1 in there, well, what does that equal? That's equal to 3. Okay, and so forth this way. And then, of course, you've got this -1 here. Well, that means that you're going to move everything down. So let's do that. Okay, so that's one way to do this. And so if you did do that, then this function right here, you're going to swap the domain and the range. So x and y, you're going to take the range from over here. That's 1, that's 3, and then you're going to put 0 and -1 there. So go ahead, and then we find those points, and then we're going to move everything down 1. So 1, 0, here it is, and that goes down 1, right? And then the other one is 1, 2, 3, -1. We're going to go down another. Okay, and so, and and you can, do a few more points if you wanted to, stick those in there. Like -2 might be another one, and what would -2 up here be? That would be the same thing as 9, right? So, and then you're going to do, so -2, and then you go down 9, and then you go over, was that, or would that be 1/9? Okay, well, anyway, so what's going to happen is, um, since this base is 1/3, it's between 0 and 1. It's like you're doing the logarithm, and the exponents end up becoming more and more negative. So they're going this way, and then they shoot up, and so this is what the graph ends up looking like. All right, so if you're going to do this, now let's look at it. There is a vertical asymptote right here at the y-axis, and at x equals 0. So you have a vertical asymptote at x equals 0, and the domain of this. What is the domain going to be? Well, it's going to be the only x values you have, right, are for x greater than 0. Now, what's the range? Now, keep in mind, this goes on forever. This goes on forever. It ends up that the range is all reals. Go on to example 7b. They want us to graph y equals logarithm base 5, log base 5 of x plus 2. All right, so this is telling you, this is minus h, so this is telling you what? You are moving horizontally to the left. Okay? All right, so they say plot several convenient points. Okay, well, I think it's easier to look at I do really think it's easier to look at the exponential and then swap them. All right, so let's get a few points from the exponential, and then we'll swap them and graph the logarithm. So if we said -1, 0, 1, okay. So 5 to the -1 power, well, that's what, 1/5. 5 to the 0, that's 1. 5 to the first power, well, that's 5. Okay, so now that means that our untransformed logarithm of x, okay, without doing the shift yet, is going to be the reverse of these things. So I have 1/5 is my x. I got 1, I got 5, and then that means that's at -1, that's 0, and 1. And you have to kind of be familiar with like the overall shape of a logarithm function. I think that might be the thing that you need. So you're just getting a few points in there, and then you're just sketching it in. So at 1/5, okay, I don't know where that is. I'm just guesstimating. And then I'm down at -1. Okay, so I'm saying, okay, that's kind of 1/5. Then at 1, we're at 0. And then at 5, 1, 2, 3, 4, 5, I am up at 1. Okay, so, and then now, what's the thing that we're going to do? We're going to shift all of this stuff over 2, right? So I'm going to go 2 over, and I have to remember I'm sort of like at 1/5. So I'm going to be over here, and then this is going to go 2 over, 1, 2, and then this is going to go 2 over, 1, 2. And so I'm doing something like, the function's doing something like that. Yeah, let me see. Like that, okay? Going down. All right. Now, I have like a little vertical asymptote going over here. Okay, so what's my domain now? What's my domain? Remember, the domain is always x greater than h. So the domain now is x greater than -2. Only those x values that are greater than -2 are represented on this graph in the domain. Now, what's the range? Well, we just have to keep in mind these things go on forever. They are eventually going to encompass the whole of the y-axis. So my range is going to be all reals. The very last example where you're going to graph the logarithmic function that you came up with in example 4, the one about the sand and the slope, and you're going to graph that in your calculator. So I want you to put this equation in your calculator, and of course S, which is the slope, is going to be represented by y, and D here is going to be represented by x. So you're going to enter in the equation editor y equals 0.159 plus 0.118, common log, base 10, right, of x in your calculator. And then before you graph it, I want you to go to your window. I'm sort of cheating on this and giving this to you just to save you a little bit of time. So in your x min, you're going to put 0. Your x max, you're going to put 10. X scale is 1. Y min is 0. Y max is 0.5. So that's like the, that's the maximum slope that we're using here. And then the y scale is 0.1. So graph that. And then the question they have for you is they said, use the graph to estimate the diameter of the sand particles for a beach whose slope is 0.2. So that means then you are going to graph the second equation, S equals 0.2 and this and y sub 2, you're going to put that there, and use your intersection feature and find the intersection. So second calc, intersect, first curve, second curve, guess, and you should find exactly what the answer is there in the book, where it says then S, or D actually, D, which is x, right, equals 2.225. So they said 2.23. And that's millimeters, I believe, of the sand particles. Yeah, millimeters. All right, that is it.